Notes 7.2, factor and remainder theorem. Let's recall how to do long division. The steps are, does McDonald's sell burgers? So the first step is to divide. So we're going to put a 1 here and underline the first terms. We're going to divide. 1 goes into 1 one time. Take an x away from x squared, that's 1x. Okay, so we're done with the first step, divide. Second step is to multiply. So I'm going to take the 1x, I'm going to multiply it with the x plus 3. 1x times 1x is 1x squared. 1x times 3 is 3x. The next step is to subtract. So I'm going to change the signs and combine them. So these cross out. 4 plus negative 3x is 1x. And then b for bring down. So I'm going to bring down the 33. And then I'm going to start over. So 1x goes into 1x one time. Then I'm going to multiply the 1 with the 1x plus 3. So that's going to be 1x plus 3. I'm going to subtract. So that means add the opposite. And 33 plus negative 3 is 30. So my remainder is plus 30 over x plus 3. What is remainder theorem? Remainder theorem states if a polynomial x minus a divides into a polynomial f of x the remainder is f of a equal to r. So that means, if you notice, this is the opposite of a, so whatever a is, we take the opposite. Whatever we plug in the polynomial, we should get the remainder. Let's see how this works. So I'm dividing x plus 3, so I'm going to take the opposite, so I'm going to plug in f of negative 3, and this is our f of x. So we're going to plug in negative 3 for the x's wherever you see x. So it's going to be negative 3 squared plus 4 times negative 3 plus 33. I'm going to do the math. Exponent is first. Negative 3 squared is 9. 4 times negative 3 is negative 12 plus 33. 9 minus 12 is negative 3 plus 33 is equal to 30. So the remainder theorem says that my remainder for this polynomial should be 30. And if you look at example 1, the remainders are the same, 30 and 30. So we're going to try this. Find the remainder of 3x squared plus 4x plus 7 divided by x minus 4. So here's my polynomial that I'm dividing into. I always take the opposite, so it's f of 4. I'm going to plug in 4 for the x's here. So 3 times 4 squared plus 4 times 4 plus 7. X1 is first. 4 squared is 16 times 3 is 48. 4 times 4 is 16 plus 7. So my I'm going to do the math. That would be 2371. So my remainder is 71. Right. Moving on, next page. Factor theorem. What is the factor theorem? Basically, the factor theorem says if the remainder is 0, then the polynomial is a perfect factor. Let's see how this works. which is a factor of the polynomial? Well, we already know how to factor this. We do the diamond, 5 and 6. What multiplies to 6 and gives you 5? 3 and 2. So my factors are x plus 3 and x plus 2. So C is a factor of that. So what the factor theorem says is if I use the remainder theorem, if I plug in f of the opposite, which is negative 2, I should get a remainder of 0. So I'm going to do the math. Negative 2 squared is 4. 5 times negative 2, negative 10 plus 6. If I do all that, that equals 0. Since it's equal to 0, this polynomial is a factor. So we're going to try this one right here. Try A. I'm going to plug in 3 for the C's, and if this math is equal to 0, then it's a factor. So I'm going to go ahead and try that. F of 3, 2 times 3 cubed minus 9 times 3 squared plus 2 times 3 plus 8. 3 cubed is 27 times 2 is 54. 3 squared is 9 times negative 9 is negative 81. 2 times 3 is 6 plus 8. So that would be 60, 68, and negative 81 is negative 13. Since it's not equal to 0, this is not a perfect factor, so I can cross that one out. I'm going to try B. So that was A. Doesn't work. I'm going to try B. So I'm going to try plugging in 4. So f of 4 equals 2 times 4 cubed minus 9 times 4 squared plus 2 times 4 plus 8. 4 cubed is 64 times 2 is 128. 4 squared is 16 times 9 is negative 144. 2 times 4 is 8 plus 8. 8 plus 8 is 16. 16 plus 128 is 144. 144 minus 144 is 0. So B works because the remainder is 0. Thank you for your time. This is Note 7.2 Factor and Remainder Theorem.